Okay, new day, new chapter. So, welcome to chapter 3, The Shape of Data. In the last few chapters, remember, we talked about collecting sample data, our experimental design principles, and then the last chapter we talked about how to organize and display data. We'll be working with categorical data, of course. All the methods that we talk about in this chapter will work for categorical data as well. But some of them are more interesting when we talk about quantitative data. So, as an example, I have here a histogram. This corresponds to the Boston Marathon in a particular year. And so this histogram represents the frequencies of the number of runners that finish within a certain time span, right? So each number down here on the horizontal axis is finish time in hours and minutes. So this represents 6 hours and 25 minutes. Here's 3 hours and 5 minutes. And each bar represents how many people approximately finished. This is for the men's section of the Boston Marathon. How many people finished in that time interval, right? So when we look at a histogram in particular, we'll work with dot plots, of course. We'll work with raw data, organized data, frequency distributions as well. And we'll have some questions about how to really describe the data, first qualitatively, and secondly, quantitatively. So what I mean by that is we'll get a general sense of how the data is distributed. So our sense of distribution is about where the center of, so our notion of average, right? Are there more data values on the left than on the right? Is it about the same on both ends? And thinking about like what the distribution of data actually tells us about the variable that we're measuring. So if our variable is finish time, right? How does this histogram help tell us about how often people or how quickly people tend to finish the Boston Marathon, right? So this sense of distribution, we're going to talk about it first in very broad terms, right? And then we're going to center and think about specific kinds of measures that we can describe the data with. So this really is the logical conclusion of our descriptive data analysis, okay? So what we're trying to perform here is what we call descriptive statistics, which is really the title of our unit. And we're going to come up with not only general trends to describe our data, but specific statistics, right? Values that summarize a sample or a population to describe three main areas that we're going to explore. So the first main area is centrality or center, which is the notion of average, right? So if you look at this histogram, where exactly or what measurements can we come up with that measure the average runner, right? So we might be thinking, oh, somewhere in this range, right? Maybe it's that bar itself, or maybe we're talking about if we balance it on, if we think about the data as balancing on a point, maybe it's here, and so on and so forth. We're going to come up with a lot of different ways, and so we're going to talk about also how the word average itself is misleading just because there's different ways of calculating averages. A different measurement or kind of measurement that we are going to be interested in is what we call variation. And variation, if you want to think about it roughly in terms of like how widely spread are our data, right? So for instance, we have our elite runners finishing in the 2 hours and something minutes. And then we've got, our people who are, just trying to work out and improve their fitness, but may not have the best times, right? And we have a lot of people represented throughout this data set. And so this will, or some notion of variation as well. Like, just how wide is this range of, what kinds of times can we get, right? What finish times do we usually think of when we think of the Boston Marathon? The last one is relative standing. And so what relative standing is, instead of thinking about the distribution as a whole, we're going to be talking about individual data values within the distribution. So for instance, how much better is someone who finishes at 2 hours and 45 minutes than the rest of the distribution, right? So how many people are ahead of them? How many people are behind? Is there a way to rank any one person or any one data value in terms of, what's the rank of somebody who finishes at the 5 hour mark and so on? So the notion of relative standing is actually really important because, as we'll discuss, relative standing gives us a way to think about outliers, right? So somebody who finishes way out here at the 8 hour mark, right? Maybe they're an outlier and their finish time isn't representative of the sample. Similarly, like the fastest people on Earth, right? They may not be representative of the sample. They're just outliers. They're way out there, not in the usual range of the distribution of times. So that's what we're going to be covering in this chapter. By the end of chapter 3, we should be able to describe our sample data distributions qualitatively and calculating and analyzing these measures of centrality, variation, and relative standing.